Hi, welcome to this video. I'm Mohammed. I'm a PhD student at Toronto Intelligent System Lab, and today I want to present our recent work at ICCV 2025, Temporally-Enhanced Self-Supervised Pretraining for Event Cameras. This work is done at the University of Toronto, and it's also supported by Vector Institute. Well, first of all, I would like to start with a brief introduction about event cameras. Event cameras are bio-inspired sensors that instead of capturing the absolute brightness, they capture the change in brightness. And because of their hardware design, they can do it for every pixel individually. So the output of these sensors are a bit different. Instead of having a frame, we have a stream of events in which any event is saying for what pixel at position XY and at what timestamp, what kind of polarity change we observe in brightness, which is either +1 or -1. So if you think about it, if we accumulate all the events since the beginning plus the initial brightness, we can reconstruct the grayscale images. Also, these sensors are offering very low latency, high HDR, and low power consumption. On the other hand, the data is sparse, and because now we have a stream instead of a frame, it's harder to process. Now the question is, how can we process events? One way is to just accumulate recent events, convert them into some kind of representation, and feed the representation into feedforward models for prediction. However, converting events into representation is not necessarily straightforward. For example, if we want to process a limited window of events like 50 milliseconds of events, maybe the input is too sparse to process. And if we want to do something like object detection, the objects might be invisible because event cameras only capture the change and static objects remain invisible. And even if we increase the window time to something like 150 milliseconds, then we will see that the representation suffers from motion blur. So finding a trade-off is not necessarily easy. But there is another alternative, sequence models. If we want to use sequence models, we process a limited window of events in every step, but we can process the whole stream eventually. So let's say we have 50 milliseconds of events and the data is sparse, and we want to detect a car which is invisible, but let's say many seconds ago the car was visible in another frame, and if the model is trained well and if it has a high capacity, it should memorize the position of the car. But training such models is not necessarily easy. We need a lot of labeled long streams of events, which is unfortunately unavailable. When the data is limited, we can use pre-training, and there are multiple pre-training methods for event data. But all of them try to only process a limited window of events and then teach the model to extract useful features from frames or representations. The issue here is the models do not learn to extract temporal information, and this is the reason that these methods are suboptimal for sequence models like recurrent models. But how can we fix the problem? Let's say we have a sequence model and we want to pre-train this model. If we have a special target that has spatio-temporal information, what if we ask the sequence model to process the whole stream of events and then predict some features and try to mimic features of a spatial target? In this case, there is a hope that the model learns to extract spatio-temporal information from the whole stream and not just a limited window of events. But what can be this spatial target? Well, one solution is grayscale images, right? Because if we process all the events from the beginning, given the initial brightness, we can reconstruct the grayscale images. What if we ask the model to process the events and predict the grayscale image? Unfortunately, this is impossible because most of the time we don't have labeled images, grayscale images, and we only have pure events. To fix this issue, we want to use methods that try to mimic the grayscale image or estimate them by only using events. Most of the existing work try to estimate the intensity per pixel. So whenever a new event is given, we update the value of estimated intensity for that specific pixel. However, empirically in our paper, we show that these methods suffer from motion blur, and one solution is to process a batch of events at once and update the pixel intensity for all pixels in our frame. Now it's time to introduce our pre-training paradigm. The first step is to process the stream. We divide the stream into non-overlapping segments and we convert every segment into histograms. The next step is masking the representation. So we make sure we are using tube masking so we don't have any information leak. And once we mask out a good portion of the input, we feed it into a recurrent backbone, our encoder, which is a string transformer model coupled with convolute TM cells. And then we ask the decoder, a small decoder, to predict our special target. After pre-training, we transfer the backbone to downstream task and we attach a task-specific head. Now let's talk about the results. In our experiments, we show if we use weights from existing pre-training methods, there is an improvement for recurrent models' performance. But the main boost comes from TESPEC, where we try to learn spatio-temporal information. And by using our initial weights, we outperform every existing method in 5 different datasets and 3 perception tasks. In semantic segmentation, object detection, and depth estimation, we use real-world datasets, and we significantly improve the performance for all of these datasets. We also show that by adding recurrency to our architecture, the runtime only marginally increases, and still we can use these models in practice. To wrap up, we introduce a new pre-training paradigm for sequence models on event data. We also propose a new event-to-image approach, which gives us less motion blur and it's more robust against noise. And also we outperform every existing method on 5 common datasets and 3 perception tasks. We also made the code publicly available with all the checkpoints. Thanks for watching.